Hey guys, sorry I'm not there today. I'm hoping that this will work. I'm going to record our lesson as if I were teaching you in class right now. So if you will go ahead and pull up your notes, they should be in Google Classroom. This is going to be day 2 of solving trig equations. Let's go ahead and look at problem number 1. You're going to see this little box come up. It's easier for me to write on the bottom. Hopefully it's not too confusing for you, but it's easier for me to write and it's more legible so you can see it. So let's look at number 1. Sine x plus square root of 2 equals negative sine x. Remember from yesterday, we are getting this where x is by itself so we can find out what theta is. So to do that, what would you think you would do first? Well, my first thoughts is let's do something with this sine x. We need to get all of our x's to one side. So to do that, we would have to subtract sine x from both sides. So then this sine x goes away, and we're left with square root of 2 equals negative 2 sine x. So on one side, we got square root of 2 equals negative 2 sine of x. Now from there, do you want to divide by that negative 2? So let's go ahead and do that. So we get square root of 2 over 2. So we could just say that's a negative square root of 2 over 2 equals sine of x. So then just like in all of our other problems, we're going to have to multiply by the inverse of sine. So that's inverse sine, or you can write arc sine. It's the same thing. So then these signs end up canceling. So we're left with x equals the inverse sine of negative square root 2 over 2. Now before we go on, I want to go back and I want you to notice the directions this time. It says to write in general form. So this time we're going to have to do that where we look at the unit circle, we're going to have to find our answers, and then we're going to have to think, does it go around pi over 2? Do we keep walking around a circle, or is it tangent where we're going to have to do plus pi in? So because we're looking for the sign, so we're looking at, hey, where is sine square root 2 over 2? What radian measure, what degree measure is that where that leg is, where sine is square root negative 2. Let me try that again. Negative square root 2 over 2. So hopefully you thought about that, and where we see that is going to be, remember, our all students take classes. So sine is going to be negative in quadrant 3 and quadrant 4. So now we have to think to ourselves, what family is it where it's negative square root 2 over 2? And hopefully you would say your 45-degree families. So we know it's going to be pi 4 something, pi 4 over 4. So in quadrant 3, remember it's one more. So you get 5 pi over 4. Quadrant 4, remember it is double 4 minus 1, so you get 7. So these are our answers if you're going from 0 to 2 pi, if that was your interval. But the directions say to put it in general form. So then our x would equal 5 pi over 4 plus 2 pi n. So if we keep walking around and around in a circle and keep adding 360 and 360 to this, then we will get all of our answers. And then we also have 7 pi over 4 plus 2 pi n. So hopefully that makes sense to you. If not, we can go over questions on Monday. So now let's look at number 2. And number 2 says 2 sine squared x minus sine x minus 1. So on this one, my first thought would be to try to factor this. So I would kind of look at this as if there was no, if it was more of like a algebra 2 problem. So you could maybe rewrite this and it might be easier for you to see what the factors are. If you could rewrite this, remember slide and divide. So you slid this over and you would have sine squared x minus sine x. So 2 times 1 is going to give you a negative 2. Remember slide and divide from last year? Or if you guys weren't in my class last year and you didn't learn slide and divide, you could do this by factor splitting the middle term and then by grouping. So let's look at this. So if you wanted to look at this as like an algebra problem, it's kind of the same thing if you look at it like this. What are going to be the factors of negative 2 that are going to subtract to give us x? Well, hopefully you said negative 2x and then x plus 1. So remember, the whole premise of slide and divide is that you slide and you multiply your a times your c, but to do that, to be able to do that, you have to balance out your equation. So because you multiplied, you're also going to have to divide out that a. So we're going to have to divide out that 2. So then when we do that, we get x minus 1. And then remember, this can be multiplied to get rid of that denominator of 2, or you can just bump it up, and you get 2x plus 1. So now let's relate that back to trig here. And to do that, our answer, or our factors, would be, instead of just sine x, that's going to have to be, instead of it just being x minus 1, it's going to have to be sine x minus 1, and then you're going to have the 2 sine x plus 1, and that all equals 0. So now, from here, we can use our 0 property, and we can just set both of these binomials to equal 0, and then solve from there. So let's do that. So we have sine x minus 1 equals 0. Well, again, we're trying to isolate x or isolate theta. And to do that, we would add over the 1. So we get sine x is equal to 1. Now at this point, we can just multiply this by the inverse sign. And when we multiply, you can distribute. And so these two, this sign and the inverse sign cancel out. So we're just left with x is equal to the inverse sign of 1. Okay, so now we think to ourselves, where is that radian measure where sine is 1? So when we think about that, where is sine 1 on our unit circle? So hopefully you said sine is 1 at pi over 2. So then if you go down and you think about this, we'll have to add this also to 2 pi n to get all of our other radian measures if it's asking for the general form. And right here, let's not worry about general form, and let's just worry about, maybe let's think about it from the intervals of 0 to 2 pi. So let me go back up, and I want to kind of write that in the directions. So let's talk about this. Since we already did general form, I kind of want to do all of the forms. So interval of 0 to 2 pi. So in that case, the only time sine is going to be 1 is going to be at 90 degrees, which is pi over 2. So we've got another binomial to solve here, and I think I'm running out of room, so I'll come down here. So we have 2 sine x plus 1 equals 0. And we do the exact same thing, add over or subtract over your 1, so you get negative 1, divide by your 2, and you get negative 1/2. Inverse both of these sides. So we get x is equal to the inverse sine of negative 1/2. So now, think to yourself again, what family, well, when is sine going to be negative? Well, sine's not going to be negative in 1 or 2, so we're thinking quadrants 3 and quadrant 4. So if we're looking at an interval of 0 to 2 pi, we're looking at both of those quadrants. So then to do that, we would get the 30-degree family, and so that would be something pi over 6 and something pi over 6. So in the third quadrant, it's 1 more, so you get 7 pi over 6. Fourth quadrant is double minus 1, so you get 11 pi over 6. So if we were looking at these solutions just in the intervals of 0 to 2 pi, our answers would be pi over 2, 7 pi over 6, and then 11 pi over 6. And that's our answer. And we could plug these back into the original to verify and all that kind of stuff to make sure that they actually work. But right now we're just going to move on to our next problem. All right, let's look at number 3. 2 sine x. I feel like all of these are kind of in sine so far, so I'm glad that we have a cosine thrown in here now. So we have 2 sine squared x plus 3 cosine x minus 3. So our problem right here is we have 2 trig functions, or 2 trigs. We've got the sine and we've got cosine. So now we have to think, how can we eliminate one or the other? So does anybody see a trig identity that we could use here? Oh, we're still in highlighter mode. Okay, so use trig identity. Anyone see it? Hopefully you see that sine squared x could be written as 1 minus cosine squared x. And that goes back to your Pythagorean theorem identities. These don't go away, we still have to use them. So if we can do that, then now we're all in cosine mode. And so what's next? Well, my thought is to distribute this 2 across here. So we get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Next, I would say let's combine like terms. Well, we've got 2 minus 3. So now we have negative 2 cosine squared x plus 3 cosine x, and then we have a minus 1. Okay, so my thought is let's factor now. But factoring, when we have this negative over here, is not good. So let's go ahead and factor out a negative so that it doesn't interfere with our factoring. So you get 2 cosine squared x plus 3 cosine. Oh, that should be a negative cosine squared x plus 1 equals 0. Now factor. Slide and divide again. So we can think to ourselves x squared minus 3x plus 2 equals 0. So what factors of 2 that are going to have the same sign to give you negative 3, that add together to give you negative 3? And that would be a negative 2 and a negative 1. So then we have to divide out because we multiplied by a 2. We're going to have to divide out by a 2. And so we get x minus 1 and bump up 2x minus 1 equals 0. Don't forget your negative. Is your negative really going to affect this? Not so much. But now we can say 2 cosine of x minus 1 is equal to 0. And then cosine of x minus 1 equals 0. So let's look at this. Cosine x minus 1 equals 0. And then 2 cosine x minus 1 equals 0. Okay, now we're just solving these. So same thing been doing. Let's add the 1 over. Then let's multiply by the inverse of cosine. So we get x is equal to inverse of cosine of 1. And if we think about that, where is cosine 1? What measurement, what radian is where cosine is 1? Well, that's 0. So now let's go back up over here and same thing. I hope this is becoming kind of easier for you to see what you need to do next. Divide by 2. So then we get the inverse cosine of 1/2. So let's think about that one for a second. So on that one, cosine of 1/2 is going to be positive in quadrant 1 and quadrant 4. So remember, all students take classes, so quadrant 1 and quadrant 4. And so in quadrant 1, cosine of 1/2, that's going to be our 60-degree family. So that's going to be pi over 3 for quadrant 1. And it's going to be something pi over 3. And in quadrant 1, it's going to be double minus 1. So you get 5 pi over 3. So let's say we want to do the general form on this one. So this would be pi over 3 plus 2 pi n. That says we're going to keep taking around our circles, keep walking around, and then 5 pi over 3 plus 2 pi n. And there we have our answer. Done. Okay. I think this is our last one. Gotta get my screen ready. All right, here we go. Cosine x plus 1 equals sine x. Let's see, okay, in this one, it already says we're just looking at the interval from 0 to 2 pi. So on this one, it's really hard for me to see if there's anything that we can cancel. But when I see that this is cosine plus 1, I think to myself, man, if that was squared, then it would be a Pythagorean theorem identity, and maybe we could do something with that. So let's take a chance and let's square both sides. Because remember, if you do it to one side, you must do it to the other. So then we have cosine x plus 1 squared equals to sine x squared. So if we have this where they're squared on both of them, then we could write cosine x plus cosine x plus 1. And then to make all of these the same, I could say, well, we know that sine x squared is equal to cosine squared x plus 1. Could we say that? Sure we can. So now I'm thinking to myself, well, this needs to be factored or foiled. Really, foiling, that's what we need to do. Foil. Let's foil this. So if we do that, we get cosine squared x plus cosine x plus cosine x plus 1. Well, these cosines become 2 cosine x plus 1. And then don't forget what you have over here in your equal sign, cosine squared x plus 1. Okay. So now my thoughts is I need to get everything to one side. Oh, and I don't have this right. This is supposed to be sine squared x is, it's sine squared x plus cosine squared x equals 1. So that means this is supposed to be, did anybody catch that? 1 minus cosine squared x. Erase. 1 minus cosine squared x. Okay, so now let's get everything to one side, and that one side is equal to 0, and then we can solve from here. So I'm going to subtract this 1 over, so those cancel. Then I'm going to add this cosine squared x over here. And so this cancels. So we have 2 cosine squared x plus 2 cosine squared x plus these cancel equals 0. So now what are your thoughts here? Do you see something that maybe we could do, like a GCF? So if we can take a GCF out, we could take out 2 cosine x, which would leave us with cosine x plus 1 equals 0. Then we could just set each one of these equal to 0. So we get 2 cosine x is equal to 0, and cosine x plus 1 is equal to 0. So from here, we're going to divide by 2. So we get cosine x is equal to 0. And so then x is equal to a inverse cosine of 0. And where does that happen? I feel like I'm making this video really long and I'm not sure YouTube is going to do it well. So let's say pi over 2, 3 pi over 2. So there's that one. And then if we do this, cosine equals -1, and then we have the inverse cosine of -1. And if we look at that, we get pi. X is going to equal to pi. So we think that we're done. However, because we took the squared of both sides of the original problem and we manipulated this, we are going to need to check for extraneous solutions. So if you go and plug these in, pi over 2, back into the original equation. So think about this. Let's go look at it with, is cosine pi over 2 plus 1, does that equal sine pi over 2? So cosine pi over 2, I'll do it over here. Cosine of pi over 2 plus 1, does that equal to sine pi over 2? And so you get 0, cosine of pi over 2 is 0, plus 1. Does that equal sine of pi over 2, which is 1? So 1 equals 1. So yep, that works. However, when you plug in 3 pi over 2 plus 1, and does that equal sine of 3 pi over 2? Let's see if that works. So cosine of 3 pi over 2 would be 0 plus 1, and sine of 3 pi over 2 equals negative 1, and that doesn't work. So that's an extraneous solution. And if you go back and look at is cosine pi plus 1, I'm running over. Cosine pi plus 1, does that equal sine pi? Well, you get negative 1 plus 1, does that equal sine of pi is 0? So yes, 0 equals 0. Check. So our answer for this one is x is equal to pi over 2. We threw out 3 pi over 2 because then it was an extraneous solution, and then pi. All right, I have a worksheet online for you guys to start practicing some of these problems. I have decided to move your quiz. So we will talk about on Monday. We will not have a quiz on Monday. Have a great weekend. Work on your worksheet that I have posted online. I'll have a great day. Bye.